That's just to list the factors which affect or which can be used to talk about. And there we've got the constructive factors. For constructive interference to occur, you have to be, we're assuming that initial setup with the waves the same wavelength and so forth, but you have to be peaks meeting peaks and troughs meeting troughs. T-R-O-U, it's a bit hard on this. Troughs meet, there we go, it's better. Troughs to produce constructive interference. And now here's a slightly more technical version of that. To any point, there must be a point where the distance from each source, the 2-point sources, from each source must be a whole number of wavelengths. Okay, so that's going to be a tricky bit, and that means that the waves will be arriving in phase. So the two waves in phase. Do you see how your idea of phase and superposition, adding waves and diffraction is all coming together in this one concept of interference, 2-point source interference? That's why it's a higher level thing. Anyway, so the two waves must be arriving in phase, and they each are a whole number of wavelengths from their sources. That means the path difference, I like to talk about the path difference, is going to be a whole number of wavelengths. So we would call it n lambda, where n is 1, 1, 2, 3 and so forth, or 0 as well I think would include. 0, 1, 2, 3 and so forth, whole numbers of wavelengths. Now let's go back and look at our diagram because it's going to help us here. And it's getting a wee bit messy, so let's just see if we can zoom in on it. Okay, now hopefully you can see this. If we consider this point here, this is one wavelength out from this side, but it is 1, 2, 3 wavelengths out from this side. So the path difference, in this case, path difference is 2 wavelengths, which is a whole number of wavelength path difference. Okay. You could also pick a point of constructive, I'll go here, destructive interference. Okay, and from here, let's go a different colour because it's just getting a little bit ridiculous with the amount that's on here. So here's purple. Let's track back. We've got one wavelength to the middle of the other one, and then we've got a half. Okay, so that's 1 1/2. And then coming back to the other side, we've got one wavelength, 2 wavelengths, and then the half down here. So we've got 2 1/2 and 1 1/2 means that we've got path difference of 1 wavelength. Okay, so that's a whole number of wavelengths path difference. Gonna have to finish there, but that's the main idea. Destructive interference is a whole number of an odd number of. No, I won't. I'll make this split this into 2 videos, so I won't finish there. Moving down, destructive interference, green because that's what we used. So for destructive interference, let's try and match it up with what we've got. Peaks meeting peaks and troughs meeting troughs for constructive. So for destructive, it's going to be peaks meeting troughs and adding to cancel out. So the amplitude is the smallest amplitude, and we would say that this is a slightly technical way of saying it, an odd number of half wavelength path difference. Okay, an odd number of half wavelengths path difference, what that means is basically the waves have to arrive out of phase, which is exactly half a wavelength difference in the way to get from one source to the other. So we'll go back up and have a quick look at that. And the odd number of half wavelengths mean you're always going to be at least half a wavelength out. So let's go back up to our diagram and zoom in again. And I'm going to have to pick, where's a good colour, we'll just go for black I think. So a point of destructive interference, here's one. Okay, so that is straight away you should be able to know it's at least half a wavelength out, because you've got a peak which is here meeting a trough which is here. So the peak is clearly 1, 2, 3 wavelengths out, but the trough has got that 1 plus the half here, causing that out to arrive with a half wavelength difference. At least it's actually 1.5 wavelengths difference, but it's at least half a wavelength out. So 1.5 wavelengths is 3 odd, or 3 half wavelengths. Okay, that's more than enough I think. Worth watching that video again to get all the details. This is a tricky concept, but it's seriously cool. And here's your smiley face for making it all the way through.